Okay, cool. So so today's lecture is on Data Science 101, which is cleaning and visualizing data. Yeah, cool. So agenda, we're gonna do. I guess Jordan covered question and concern. So we're gonna do an outline, and then some of the tools and techniques, and then we're gonna jump into a motivation, which will launch us to like a live coding session, which is gonna be the bulk of the lecture. So yeah, what do you did this? So outline. So data is really powerful. As you know, it can explain a lot of phenomena in our real world. So today we're gonna look at how data can elucidate some real world problems. So basically today's lecture is gonna be a full like end-to-end experience in Python from like our question to getting some results. And it's really for you to get a feel for how to frame a data science problem and how to go investigating it. So along the way, we're going to discover some of these tools and techniques. So we're going to learn about pandas, which is to manipulate data frames, matplotlib, which is for visualizing data, datetime, which is like a Python library, and a few other Python tricks. So feel free to stop me along any time of the lecture, just like raise your hand or anything, or tell me I'm going too fast, if I am. And yeah, so also if you go to the GitHub, you'll see under lecture 2, so data science 101.ipynb is like the whole lecture for today. So you can find like all the code that I'm going to write up today here, like all with the graphs and everything. So if you ever get lost or something, like, you can just ask me, or you can refer to this doc too. And only code.ipynb is like literally just the code for the lecture, not like anything else. And it like types out like literally everything that I'm going to type out today. So like if you're ever lost, just like look at that too. So yeah, those are 2 resources. And then there's also another file called lecture starter. So you guys should open that Jupyter notebook, and it just tells you to download this data set and then import these things. So has anyone tried this? Like, do all these imports work for everyone? Can you guys raise your hand if they're not working? Okay, awesome. And who does not have that data set downloaded? Okay, a couple people. Try to download it like right now. If you can't, like it's not a big deal. You can always just like catch up later. Okay, sweet. Yeah, so back to motivation. So what's our motivation? This is our motivation. So yeah, this happened. So I was curious, like how could something like this happen? I didn't fully understand some of the results, and I kind of wanted more answers that would explain like what happened in this campaign and what led to these outcomes. So I started thinking, what's one real-world phenomenon that greatly impacts campaign results? Campaign donations. So, okay, we have campaign donations. Let's explore that and see if we can come up with some interesting results. So, the FEC basically holds like all of the campaign donations in a publicly available format. So I can just search FEC campaign donations 2016. Go here to the website, which is like the website that I linked you guys to, and my internet works. Hello, Air Bears. Okay, cool. Yeah. So this kind of like gives you all the contributor data, and you can like export it. And I told you to download all.zip, which all.zip just contains the contributions for every single candidate and every single person that contributed to every single candidate. So we want to take a look at this data set. So you guys should have downloaded this data set, which is great. So now that you've downloaded it and unzipped it, it should be called 2016. Just rename it to 2016 donations.csv. Yeah, so I'm just going to pull it into the data science decal folder and move it into lecture 2. Okay, so it's easier. So yeah, so just open up your terminal, and you want to go into where you downloaded the GitHub repo. So wherever the data science decal folder is on your computer. So for me, it's in here. Oops. So this is like the repo, and then down here I can find lecture 2, and I can go into that folder. And I should have my like donations.csv in there. So I have this donations.csv. I kind of want to explore it, see if I can find any answers from it. So what am I going to do? Am I going to put this into like Sublime or open it in Microsoft Excel? This is like 200 megabytes. It's not going to work. So what I do is I open up a Jupyter notebook like this. I can create any Jupyter notebook by just typing Jupyter notebook. You guys should use the Jupyter notebook lecture starter. And I can do new Python 3 file, and it'll open up a new Python 3. Cool. Oops. Issues. So first thing I'm gonna do is I'm gonna just import like all the stuff that I'm gonna need. So import. So by the way, you guys should be typing along this, doing this along with me because I'm doing it. So import pandas as PD. We just use these abbreviations because they're easier to work with. Import numpy as np. Import matplotlib.py as plt from collections. Import default dict, and don't worry, I'm gonna go over what all of these do later on. Import date time as dt. Import matplotlib.dates as mdates. Okay, cool. Oh, by plot, yeah. Okay, cool. So so Pandas, as I talked about, is this great tool to read in datasets and kind of mess around with datasets. So let's use Pandas to read in the CSV that we had originally. So I'm gonna do df, which stands for data frame, equals pd.read CSV, and I literally just passed in the name of my CSV. So as I saved it in 2016 donations.csv, and that's all I do. And now Python, the Pandas framework will go in, it'll read the CSV and store it in df. Does anyone have any questions as to what I've done so far? Is everyone following along? Okay, cool. So the dataset is kind of big, so it'll take some time to load it. In the meanwhile, I'll just talk about like some of the things you can do with Pandas. Oh yeah, question? So the CSV I told you guys to download it. It was the big dataset. Oh, so wherever you downloaded it in. So if you download it, if you just click the all.zip, it should be in your downloads folder. Yeah, just move it into the like GitHub folder, into the folder with the GitHub directory. Yeah. Okay, cool. So basically now it says that we've loaded the data frame. So we want to take a look at what this variable df has stored. So I'll just show you what df is. So it's this like big data frame kind of looking like this, with like a bunch of columns and rows. So we can kind of take a look at see what's here. So we can see that there's like a candidate ID, a candidate name. We can see like, oh, some donations went to like Marco Rubio, for instance. We can see like contributor city that went to Washington. Now this looks kind of funny, right? Like contributor cities on this column, but the city is actually listed on this column, or the name is on here, but the name is actually to the left. So this actually what happens is that this leftmost column here is actually the commit ID or CMT ID. But Pandas just treats it as the index column, so that's something you can index into. But obviously we want that to be a new column. So the quick way to fix this is to, when you're loading your dataset, you just do index call equals false. And that'll reload the dataset with all the rows shifted one to the right, and that'll fix our problem. So things like these are just like common things that you'll come across when loading in a dataset, that just like your dataset's not going to be clean or an easy to read format, and you have to figure out what's wrong with it and adjust kind of like on the go based on like what you're doing. So once that's finished reading, we can re-hit df and kind of see what happens.
Can you zoom in? The people in the back.
Oh yeah. Is this better? Sweet. Okay, cool. So it's almost. Okay, so now it's read it. So we can run that df cell again, and there we go. Now all of our stuff is matched up correctly. So candidate name matches up correctly with Marco Rubio. The city matches up with Washington, Atlanta, whatever, etc. But this like big kind of like boxy thing in our Jupyter notebook is kind of weird. Like it's not really easy to deal with. So a quick way to get a quick overview of your dataset is to just do df.head like this. And what that'll do is like it'll make it like nicely scrollable and like just a few lines so you can really easily see what's going on in your dataset. So that's a really good tool to use just to get a quick overview of your dataset. Now let's explore some more statistics about your dataset. We can do df.shape, and that'll give us the shape of the matrix. So for example, here we can see we have about 7,440,000 entries and 18 columns. So each of the columns refers to something like one of these up here. And we have like 7 million entries, meaning about 7 million people have contributed. Yep.
Every time I try to run the TMC, I'm getting kernel has died as it just pops up.
I think that's like a Jupyter thing. You might want to try like just restarting your Jupyter kernel. Seeing if that works. Yep. Okay, cool. So we have df.shape. Let's see if we can pull out some more interesting statistics. So another cool thing is df.describe. And that'll basically compute a list of the summary statistics of the numerical data in our data set. So for example, if you look at the numerical data, so one of the things is here, contribution receipt amount. That basically means how much money has that particular person contributed to that candidate. So we can see for this person has contributed $175, for example, this person $25, for example. And if we do df.describe, it'll give us these summary statistics, for example, of the numerical data. In this case, we had 2. File number we don't really care about, but contribution receipt amount, we can see like some statistics. Like the average contribution was $126 across all candidates for the 2016 election. Cool, that's interesting to know. Another thing, if we want to just explore all the columns we have in our data set, we can do df.columns, and that'll show us all the possible columns. Now suppose I wanted to look at only one of the columns available. I can either index into it like a dictionary, so I could do df, and then suppose I wanted to see the receipt amount. I could do that. It would find me like all the values of all the contributions in the data set. Or a really cool simpler syntax is to just use the dot notation, and that'll still work. And of course, you can always do dot head on this to get just a brief overview and summary of like what your data looks like once you filtered it. So now let's kind of go back to our data set that we have here and explore it more. We have 18 columns, but we really don't care about all these 18 columns. Some of them are random, like trends, ID, I don't know what that is, or memo text. We don't really care about them. What we do care about, for example, are the candidate name, the receipt, the contribution date, the contribution amount, the person who contributed it, and like the election cycle, just to know if it was during the primary general election. So a really easy way we can do that is by just indexing with a list of columns. So here I can just pass in a list, candidate name, cont receipt date, cont receipt amount, and contribution name, and election TP. So it's literally just like a list within the indexing of the data frame, and I can store it in a new data frame called contributions. Ooh. Oh, election. It should be election underscore TP. Cool. So now if we look at contributions, it looks something like this. We have the candidate name, the receipt date, the receipt amount, the person who contributed the amount, and the election cycle. Cool. We filtered our data set to just the values that we care about. Anyone have any questions so far? Yep.
Why is it a list of the list?
Because so just the single bracket is like indexing into the data frame, and then you want to pass in a list into the index. So you pass it. You have another 2 brackets for the list. If it was just a single value, then you could just pass in that one string. But if it's a list, you kind of have to do these double brackets. It's just like a Python syntax type thing. Yep. So now we have these contributions. So we can see that this data set looks pretty good. But when we scroll down, we see these like NaN values on the right. So that's not good. Why do we have NaN? So you can have NaN or not a number in your data set for a number of reasons. One, there's simply no value in there. So like whoever is collecting the data couldn't find a value for that specific cell. So they just put NaN, or like they left it blank or something like that. So Pandas treats it as like NaN, and you'll see that pop up. Now, there are a few things you can do with NaN. You can either like drop the whole row, so it like completely eliminates all the like null values that I have in your data set. So after that, you know that your data set's completely clean. Or you can do something called missing value imputation, in which you kind of like use summary statistics to try to make your best guess at what this value could be. You're going to explore missing value imputation in the homework, so I'm not going to touch on it too much. So for right now, we just want to deal with the clean data set, so let's just go ahead and drop it. So let's say that our clean contributions is contributions dot drop NA. So that's just like a pandas function that literally it goes through every row. If there's a row in any one of the, if there's an NaN in any one of the rows in any column, it'll just drop that row. Okay. Am I going too fast? Yeah, question in the back? Oh. Question? Yeah. Oh, sorry, could you speak up? Sorry, I can't hear you. Could you speak up a little? Oh, so this, do you know how to get to the class GitHub? Yeah, you can find all of this code like on the GitHub. It's called datascience101.ipynb in the lecture 2 folder. Okay, okay. Guys, we're gonna revert to the posting on Piazza thing because that'll be easier. Sorry. Okay. Okay, so now we have our clean contributions. So we can do clean contributions.shape to take a look at what our shape is, and we get something like this. So that basically means that we have like X amount of rows and 5 columns. Now we kind of want to verify that what we did in dropping the rows is accurate. So what we can do is contributions.shape 0 minus clean contributions.shape 0. So that this will basically tell you how many rows had an NaN value that we dropped. Because contributions was before we did drop NA, and clean contributions was after we dropped NA. And we can kind of verify this with another pandas function called pd.isNull. It'll basically return a true or false for every single entry in the data frame that you pass it in and saying whether it has NaN or not. So I could just say pd.isNull contributions election TP. And then I want to sum over all the values, so I can just say sum. And it should spit out 14,022, as in the above case, because they're both equal quantities. So yeah, that should happen. Cool. Yeah, that'll take some time to run. Then it'll spit out the value. Okay. So now, yeah, exactly. So now we have this clean contribution. So let's take a look at what our clean contributions looks like. This is our new data set that we're working with, and we know that this data set has no NaN, no like missing values. It's a clean data set. We can totally work with this. Is totally good. Awesome. So now we can filter out and see like how many different candidates there were that received money. So we can do clean contributions.canned_nm.unique, and that'll basically pull out all the unique values of that column. So this column refers to the candidate name. So it'll basically pull out all the people who have received money. So we can see like Marco Rubio here. We can see Hillary Clinton here, Donald Trump, Bernie Sanders. Yeah. Cool. So now what we want to do is we want to our whole goal is to just discover whether election contributions kind of impacted the campaigns and the election. So let's kind of filter these and split these up by different candidates and see whether we can draw some interesting statistics. So we can do Trump contributions equals clean contributions, and then clean contributions dot canned nm equals Trump Donald J. So basically what I'm doing here is I'm saying index into the clean contributions and select every row in which the candidate name field equals Donald Trump or Trump Donald J. And this will basically give me a data frame with only Trump's contributions. So for example, I can see Trump const.head, and we can see these are only the contributions that went to Donald Trump. So now we can again do some summary statistics and find out what was the average contribution for Donald Trump. So we can do Trump const.describe. Here we go. So we can see that the mean of the receipt amount, which is how much it was donated, is $156. So on average, people donated to Trump $156 for each of the contributions. So let's kind of pull this out for each candidate, or the interesting candidates, and see what happens. So Bernie const equals clean. You can just clean contributions dot canned nm equals Sanders Bernard. So we basically did the same thing for Bernie Sanders, and then we can do Bernie const dot describe. Cool. And what do we see here? We see that the average contribution for Bernie Sanders is about $48. Now that's a big difference. For Trump it was 155, and for Bernie it was 45. It was like 45. And like if you follow the election, what a lot of people said was that Sanders kind of like had a more grassroots campaign, and he accepted a lot more donations from like less wealthier people, but a lot more donations. So we can kind of see like a reflection of that. Basically, his like average contribution was way lower than Donald Trump. So we can do the same thing for Hillary Clinton. So Hillary const equals clean contributions. Clean contributions can nm equals and pull out Clinton Hillary Rodham. And then we can do the same kind of summary statistics for Hillary Clinton. And we get that the average donation to her was 130. So comparing her and Donald Trump, we can see that Hillary Clinton was 130, Donald Trump was at like 150, 160, somewhere there, and Bernie Sanders was like 45. So clearly like Sanders is like way different than like the two candidates who were in the primaries. So that's like an interesting thing to note. So now we have like, forget about Bernie Sanders, like Hillary and Donald Trump were the ones in the primary, in the general election. So let's just focus on that. We want to see their contributions over time, and we want to be able to kind of visually see them. So now what we're going to do is we're going to take their contributions, and we're going to plot them, and we're going to compare them. So in order to do that, like this data set is kind of big, and I don't want to deal with so many values like filtering and plotting them because it's going to take too much time. So what I'm going to do is I'm just going to filter out the values that are just greater over 100. So filter out values for contributions amounts who are over 100 just to speed things up. And it'll like relatively keep the same shape of the graph and the data set. So the one way we can do that is to do this. Hillary const short equals Hillary const and then absolute value of Hillary const dot cont receipt amount is greater than 100. So basically what I'm saying is index into Hillary const or Hillary contributions and select the rows in which the absolute value of the contribution receipt amount is greater than 100. And that will store it in a new data frame called Hillary const short. So I can run that. And then I can do the same thing for Trump. And since I don't want to rewrite it, I'm just going to copy paste. So I can change this to Trump. Trump. Am I going too fast, or hands up if I'm going too fast? Okay, I'll try to go a little slow. Sorry. Oh yeah, good question. So there's this thing that a lot of candidates do. If you're a particularly wealthy donor and you want to donate a lot of money, there are like restrictions that there are like laws that say you can't donate like past certain like an X amount. So what a lot of people do is that they'll donate a lump sum to one candidate, and then the candidate will refund whatever is the extra amount that is not allowed to their spouse, and then their spouse will donate that. So that refund is kind of counted as a negative donation. And if you just like research like campaign finance a little bit, you'll like see, and like you can actually trace like people in this data set to like things that they've done like based on like the negative amounts of the contributions. So it's like kind of cool. But yeah, it's like something to think about if like you're interested in this more. Yeah, okay, so now we have Hillary contributions and Trump contributions. Sweet. Okay, so this next section is going to be a little bit complicated. I'm going to write out a function basically to take a data set and extract the dates and the contribution amounts and turn it into a pair of XY points so that I can plot it. So everyone, I want you to just like stop typing and look up on the screen. The code is exactly like in the GitHub, so you can just copy paste that right afterwards, and I'll give you some time to do that too. So if you guys just like pay attention, it'll be like a lot better than like you trying to type out what I'm doing here. Okay, so I'm gonna define a function to donation XY points, and that will take in like a contributions data set. So I want to create like a donations dictionary. That'll hold basically the index will be the date, and the value will be the amount contributed on that date. So I'm going to do default donations dict equals default dict lambda 0. So what exactly is a default dict? So a default dict is basically a dictionary, but instead of having to deal with initializing like a key every time you want to like create a new key or something, it'll just default to this value that you pass into it if none already exists. So if I try to access like say date May 13 and May 13 doesn't exist in the dictionary, it'll automatically create one with a key of May 13 and a value of 0, for example, whatever value I pass into this lambda function. So that's what donations dict does. Now I can kind of like iterate through the rows of the contributions data set. So I can say for index comma row in contributions.iter_rows. And so first, so if you look at our data set, you kind of see that our date is stored in this like kind of string formatted like this. We want to turn this into something that Python can understand. So a datetime object. So an easy way to do that is to just do date equals dt.datetime dot strip time, which basically strips the string and returns you kind of like the date representation. I'll just say row dot cont receipt amount or receipt date, and then I have to pass in like the formatter for what kind of like the date looks like. So here the formatter is b year. That just means date that day month year. So if you look up here, that's going to write as day month year, and like this is just like documentation you can look up. It's like fairly standard. So I do that, and then I just index into donations dict, and I use that date as the key, and I increment that value by whatever the contribution amount was. So row.cont receipt amount. Does that kind of make sense what I just did here? Does anyone have any like general like questions of like why I did this? Okay, yeah. Iterrows basically returns an iterable. So this just like gives you like every index. You just loop to give you every index and row in the data set of contributions. So we have this, and now we have basically a dictionary that has the key of the date and the value of all the contributions on that date. We want to return this as like a sorted list of XY pairs. So we can't just like extract the keys and the values separately and sort them because they'll be out of order. So what we want to do is use like a handy Python function. So we can do sorted donations dict.items. So this will like pair each of the values in the donations dict as like a tuple of like key and value, and it'll sort it by the key, and then it'll return it to you and sort it by date. And now when we want to return an XY kind of like to an XY pair, a list of XY pairs, all we have to do is return, and we're basically unzipping this XY pair. So we just do sorted by date. So this zip star just means unzip whatever this is. So it'll return to you like kind of like two lists, one of the X's, one of the Y's, and they'll all be sorted in sync. Okay, now so everyone go copy this from like the Data Science 101 or only code. Just this block and run this. Yeah. Anyone have any questions while you guys do that? Yeah.
What is donations dict.items?
So donations dict.items. So donations dict is basically a dictionary of key and value pairs. So items will return like a list of like key value tuples. So key value like pairs. So each item will be both like will hold a key and a value.
And it's sorted by the key.
Yeah, sorted by the key. So the reason I did this instead of just saying donations dict.x sort and then donations dict.y sort is because if I just sort them independently, they'll be out of sync, and I kind of want to like keep the keys and the values sorted together. Yep. Okay, cool. Now I have this, so now it's really easy. Now all we have to do is we just call the function. So we just go to donation xy points, and let's say we want to plot Hillary's contributions first. So we say Hillary cons short, and then we can store this as hill x, hill y. There we go. So this will go through and this will like do all the math and it'll return us like a list of X points and Y points for Hillary's contributions. And now we can start plotting. So matplotlib, as you remember, we did import matplotlib.pyplot as PLT. So every time you interact with matplotlib, which is your plotting software, you're gonna use PLT in some sort of way. It's gonna be a function call off of PLT. And the way PLT kind of works is first you create a canvas on which you plot, and then you plot whatever you want to, and then you show the plot at the end of all the stuff you've done. So let's go through that here. So we want to create a figure or a canvas. So you do plt.figure, and then fig size, we can just pass it in a tuple of 2010. So this is just saying create a figure, and we can say size 2010, just so it's like big on the screen. Now we want to plot the points. So it's easy as just plt.plot, and we pass in hill x, hill y. And then we say plt.show. So when we run this, it'll create the figure, it'll plot the points, and it'll show it. Now, what if you wanted to, say, plot multiple graphs on the same canvas? That's fine. Just call figure, and then do plot x and y, then do plot x2, y2, and then show. And it'll show that figure with both of the graphs plotted on the same canvas. If you wanted to create 5 graphs, that's fine. Just do figure, plot, and then show. And it'll show all those five canvases all at once. So that's kind of like how matplotlib works and like how the structure of it evolves. So now we have hill x and hill y finished running, and we can just go ahead and plot it. So it looks something like this, basically. So these are the dates on the bottom that you can see. So that starts at like May 2015, and it goes until like December 2016. And this is kind of what it looks like. Now, first, right off the bat, you can see like a few interesting spikes, like here, and like, why are there so many spikes that like all of a sudden they seem kind of random? So, that's interesting. Let's kind of look at that further. So what we can do is we want to see basically like what these largest values are and who contributed these largest values. So we can just simply sort by the contribution amount, and that'll give us like the top rows with these top values. So what we can do is Hillary const sort values, and we pass in what column to sort it by. So here it's going to be how much they donated, which is contribution receipt amount. And ascending is false because we want to see the most, not the least. So here we go. So you can see these like large sums of money, and they were all contributed by this Hillary Victory Fund unitemized. What is this Hillary Victory Fund? So let's just like copy that and paste that into Google because Google knows everything. So you can see here it's basically like a fundraising committee. Okay, so that explains it. Basically, this Hillary Victory Fund is just aggregating like contributions from a bunch of people, and then on one date, it's just like dumping it all into like Hillary's fund. So with all these contributions, they kind of skew our graph because they don't show like over time like how the donations have progressed. They just like dump it all in one date. So what we want to do is we want to get rid of those values and see kind of like a more gradual like contribution over time that looks more realistic to what people actually contributed. So we can go ahead and do that. So we can do Hillary const, just call it real, and we can basically say we want to index into the data frame, the original data frame, and we want to say wherever the contribution name does not equal this like Hillary Victory Fund unitemized. So basically we're saying here index into the Hillary contribution dataset and do not choose the rows in which the contribution name equals this Victory Fund unitemized. Oh, and I have to put quotes. Yeah, and do not choose those and store it in a new dataset called Hillary const real. Now we can kind of like do the same thing. So we can like plot it now that we filtered it out. So hill x2, hill y2 equals to donation xy points Hillary const real. Oh, XY points. Okay, so this will again call that function and it'll give us the X and Y values back. And now we can do the same thing as we did before. We can do the plot.figure, the plot.figure, the plot.plot, and the plot.show. So plot.figure fig size equals 2010 plot hill x2 hill y2 plot.show. And after this happens, after this finishes running, we'll kind of see like what that looks like. Okay, I'm gonna wait while I wait for it. Like, did I lose anyone? Am I going too fast? Anyone have any questions? No questions? Sweet. Okay. So yeah, okay, let's just wait for that to run. So yeah, this is kind of like why. Okay, here we go. So this graph looks a lot better. This is like now we can see a lot more fluctuation and like we can see some spikes, but they're not as bad as they were before because of like the dumping of that victory fund. So yeah, okay. So now like we have like a few spikes like this one here, this one here, this one here. So we're still interested into like what caused those spikes and to try any like association between what we know about the election and like what we're seeing in our data set. So one way to kind of figure out what exactly these lines are is to use like a plotting function called axvline. So what we can say is plt.axvline, and that just puts a vertical line on whatever x coordinate you give it. So we can say axvline x equals dt.datetime 2016. I'm just gonna guess July 26th. And C equals pink, just it's a pink color. So I'm gonna say that. Now it's gonna be an intelligent guess because I did this before. But yeah, so July 26th is literally like the day before this big contribution spike happened, and you can kind of see like this line here, and that's the contribution spike. So and the graph looks like this basically. We just plotted like a vertical line where we thought the spike was gonna be. So if we like search up what happened on July 26, 2016. Maybe that'll have some interesting results. So, 10 things you need to know today. Okay. Here we go. So, here we go. Let's see. Well, I lost the exact article, but there's an article that basically says that this was like the opening night of the Democratic National Convention, and President Obama like endorsed Hillary Clinton, and like a lot of people respected Obama. So like that's like one plausible reason why we see like a big spike in contributions. So yeah, so I can do the same thing for like these two spikes over here. So I can say so I know one's gonna be 9:26 and the other is like 9:30. And we can see that they like line up with the spikes that we see over here. And basically on September 26th, that was like the first presidential debate with Donald Trump. So we can see like that brought in a lot of contributions. And then on the 30th, the first polls were released showing that Hillary Clinton like won that first debate and that she was like ahead in the race. So that like brought in like the bigger spike, riding on the wave of the previous spike. So like I'm not saying that all these like occurrences on these dates like were like the sole factors for these spikes over here, but I'm saying they're like very plausibly like a major cause of like why we see the spike in contributions. So yeah, that's kind of cool. We like tied like boring graphs to like something that happened in the real world. So sweet. So let's analyze Trump now. It's gonna be fun. So we can do Trump x Trump y equals 2 donation xy points, and we pass in just the Trump const. Sure. Remember we already have this data set, so we just like call this function to get his x and y points. And now we can do the same thing. So I want to plot Trump's contributions side by side with Hillary's. So remember the way I was talking to you when I showed you how to use matplotlib? So you first want to define the figure, and then we'll plot Hillary's and Trump's at the same time, and then we'll call plot.show, and that'll show us like both of their contributions plotted side by side. So yeah, let's do that. So let's do plot.figure fig size equals 20, 10. This is like standard. Now we do plot.plot hill x2 hill y2. And to make the graph a little cleaner, I can add like a label. So I'll say this label equals Hillary. C is just for the color is blue. I can do plot Trump x Trump y label equals Trump. C equals red. Cool. And since I have multiple things, I can do like a plot.legend call like this, which will basically add a legend to your plot. And you do it typically after you've plotted all the things and before you call plot.show. So we'll add a legend to the canvas. So we do plot.legend and plot.show. So here we go. This is, the blue is Hillary's contributions over time and the red is Trump's. So one thing we can notice right off the bat is that Hillary has been receiving money for like a long time, like well before like the election was like in full swing, even the primaries. While Trump only started to gain traction like very recently, like where does it say, like this is like June 2016. So we can see that like Hillary's campaign like might have been more organized to be soliciting these funds from way earlier on. Or maybe people just didn't know about Trump or like didn't take him seriously until later on. So we can see like, yeah, like Trump has like only started receiving these contributions after like, June 2016, while Hillary has been getting them for a long time. So that's like another thing to think about when you're like analyzing the campaigns and like how the campaigns have been run. We can see like based on the contributions, like we can see like with like based on the contributions, like what it backs up. Cool.
Excuse me?
Yeah.
What's with the massive negative spike near the end?
Oh yeah, that's what I was like explaining to him earlier. Basically, like there are like certain legal limits that like people can only donate like X amounts to a candidate. So if a really wealthy person wants to donate more to a candidate, they just donate a big lump sum, and whatever is extra, the candidate will refund it back to like a spouse or someone close to them, and then the spouse will donate that on their behalf. So like negative spike like usually means that like this money is refunded to someone else. It's not necessarily the case here. I mean, I haven't looked at this specific scenario, but that happens a lot. Yep. Okay, cool. So now we can do the same thing here. We see a couple spikes in Trump's contributions. One over here, one over here. Those are like the kind of biggest spikes. So let's kind of like analyze those. So we can do the same thing where we did plot.axvline, which is just a vertical line. We can say x equals dt.datetime 2016 6/21. C equals pink. And do the same thing here for the other date, which is 10 and 20. So yeah, these like vertical lines kind of like correspond to like the dates on which you see the spikes. And so a little bit of research shows that this first date, June 21st, is Trump's speech at the Republican National Convention, and this second date, 10/20, is the last presidential debate, which many people thought that Donald Trump did pretty well at. So you can see like that like directly influenced his like contributions. So that's pretty cool. So let's we understand like, okay, like we see this data, we see these contributions, and we see like how certain real world events can tie into like some plausible spikes in this data. But I really want to understand some of these candidates on a new level. So I was thinking like, okay. So I was thinking like, okay, like what other factors are there that could possibly affect their candidate's popularity or how well they do? So for Trump, one thing came to mind: his tweets. So let's go ahead and analyze his tweets. So there's this thing called the Trump Twitter archive. Yeah. So just go here. So just like look at this, and then we're gonna do attendance right now. Yeah.
Cool. So today, to get your attendance points, you will go to tiny TinyURL.com/DSD day 2. And don't just fill this out and leave. It's not fair to everyone. And bro, I have bodyguards at every door. We will run and catch you and make sure that bad things happen. So don't just fill out the form and leave. Yeah, so fill this out, and we'll give you a few minutes, and then Tower will get back to some other cool stuff. While you're filling it out, tinyurl.com/DSD day 2.
DSD day 2.
It's hella good.
How do I do this? I can't type. Day 2. What?
What a break. You? Can you highlight everything then?
Okay, sweet.
Hell yeah. Maybe that one. Oh.
Oops.
It's too big. Half the size. Nice.
So while you're filling out the forms, I did want to give a little speech about data visualization. So what Rohan is covering today is really kind of like awesome stuff to get started. But in my kind of, I think I'm well versed enough to say this. I think visualization is the most important thing in data science, no doubt. And that's because no one's going to care about what you do unless you're able to present it to them and convince them that you're right. And for most people who don't understand data science, visualization is the only way they can see things visually. And so there's a lot of plots and graphs and visualizations that we won't cover today, but that for your own benefit, it's really good for you to understand these things. So histograms, even pie charts are useful a lot of the times. Scatter plots, which we haven't talked about today. There's so many kinds of visualizations, and Matplotlib and Seaborn and all these visualization packages are extremely powerful tools that can make all these things very easy to do. So what we don't cover today, don't think that we only cover the most important things today. We just don't have time to cover all of the visualizations that we can do. And so I really encourage you guys to go to the Matplotlib documentation, see what kind of graphs you can do, and experiment on your own. Because at the end of the day, visualizations are king, and it's all the models that we'll teach you starting next week and going to the end of the class will be great. But unless you can summarize them in a convincing way, they won't mean anything. That said, I'll kind of give you a preview about what's coming next. So today is one of the last kind of coding-heavy live demo days. Starting next week, I'll be talking about one of the most fundamental things that data scientists do is linear regression. But I won't talk about it maybe the boring way that you're used to. I'll talk about it from a really like machine learning perspective. I'll talk about gradient descent and model selection and give you a lot of like stuff that's fundamental for you to be data scientists. And then subsequent lectures will be mostly like that, where we talk about a model or two a day, as well as miscellaneous topics such as good practices and other stuff. In the back, hey, in the back, leaving right now. Are you fill out the attendance form? You did? Why? If you're leaving. Okay. I'll just take off your name. It's okay. Thanks. I know I was serious, you guys. It's not fair for all the people that have to stay. People leave early and get the attendance points. If we're going to have mandatory attendance, everyone has to stay the whole time. And you get 3 drop days, so you're allowed to miss 3 days, and I think that's pretty fair. But to everyone in the class, I think it's only fair to make. If I'm going to make you stay the whole time, everyone just stay the whole time. And I'm sorry about that. Yeah. So basically, the format of the subsequent lectures will be about an hour of content where we introduce the model, the theory, some really practical stuff, and then the last half of the class will be a demo like this, where we go through how to implement this stuff in sklearn or whatever other libraries we use. But yeah, I think you've had enough time to fill out the attendance sheet, so I'll give it back to Tyree to finish his awesome lecture. Are recording, by the way.
Okay, did everyone fill out attendance? Okay, sweet. So yeah, this is like Trump Twitter archive that like stores every one of Trump's tweets. So we can like export like a specific date range. So if we're looking at like the candidate, like the election cycle, we can export like maybe like 2016 data and see that. And like a couple other options you can configure and whatever. So I actually like did this for you and it's in the GitHub repo. It's called trumptweets.csv in the lecture 2 folder. So you don't need to do this. So just go in there. Like if you're already in there, you're good. Otherwise, just move it to the folder where your IPython notebook is, so we can read it into the pandas data frame. But yeah, basically like there's this tool where you can like see all of Trump's tweets. Awesome. So let's go ahead and analyze his tweets. So we can say tweets equals pd.read CSV, just as we did at the beginning of this lecture for the election contributions. And we can say, I think I stored it as Trump tweets.csv. Yeah, cool. Again, we want to like see what our dataset looks like. So what did we say beforehand was a good tool to use? Tweets.head. So we can do that. So we can say, see, there are a few fields. There's a source field for whether it's iPhone or Android. There's a text field, whatever he like the meat of the text, when he tweeted, the retweets, favorite counts, and if it's a retweet or not. So that's kind of cool. So we have this like data set, and we're trying to like get some insight onto like what Trump is tweeting. So if you guys do like a little bit of research, you'll find that this Twitter for Android and Twitter for iPhone actually has significant meaning because Trump's personal phone is an Android. So when it's Trump himself that's tweeting, it's Twitter for Android. When it's Trump's staff that's tweeting, it's Twitter for iPhone. So that's an important difference. So let's exploit that. So we can do Android equals tweets.source.string.contains Android. So basically what this does is indexes into the tweets data frame, and for the tweets.source field, if we just do tweets.source, that kind of returns like a pandas series object, and you can't really do like a string contains method on it. So we do .str to convert it to a string, and then we can search for whether it contains Android. So we do that, and we store it in the Android data frame. And now we can do like android.head just to see if our calculations were correct. And yeah, it's all Twitter for Android, so that's pretty cool. Let's do the same thing for iPhone. So iPhone equals tweets, tweets.source.string.contains iPhone. Cool. So now we have Android and iPhone both split up by whether it's Trump or his staff. Cool. So what we can do is, hold on, give me a sec. Okay. Yeah. So suppose you want to compare like how many times Trump tweets about Hillary versus how many times his staff tweets about Hillary. So we can say sum of android.text.str.contains Hillary. You see like 161 times. And if you want to say iPhone, then we see 145 times. Okay, so it's like not that different. Let's like look at some more interesting terms. So let's kind of like look at Hillary, and then let's plot like in a bar graph the differences in the kind of mention rates between iPhone and Android. So again, we'll use matplotlib for this. So let's say our search string equals Hillary. That's what we're looking for. And then we're gonna do sum of iPhone.text.str.contains this search string divided by length of iPhone. That's basically like the percent of times out of all the iPhone tweets he's tweeted about Hillary. So we can just call that something like, yeah, iPhone C, and then Android C equals the same thing but for the Android version. Android. And now we want to put this in a kind of bar graph. The iPhone C is just a number, Android C is just a number. We want to put this in a bar graph. So it's really easy to do. You just do plt.bar, and so this basically says create a bar graph, and the 0th bar, or like the first bar, but 0 index. So 0th bar is just going to be iPhone C, and we're going to call label equals iPhone. And then we're going to do plt.bar. This is the first bar, Android C, label equals Android. And then we can do plt.legend, plt.show. So like same like workflow we've used in the past, and we do that, and we get this kind of bar graph. So why is there like nothing for the Android column, even though we like saw that there was like 161 hits? Well, that's because our search string here was lowercase and above it was uppercase. So in order to remove that, in order to like delete that discrepancy, what we can do is do like this bracket, weird looking like bracket question mark I thing, and that just means like ignore case. Yeah, I didn't know that either. I had to look it up to find that. But so once we do that, we can see that like the relative rates between Trump is green and his staff on the left is blue. So yeah, that's for like Hillary. What if we wanted to compare like other things he tweets about? Suppose like crooked. So yeah, we can see Trump tweets a lot more crooked than his staff does. What about, I don't know, sad? Yep, that's definitely a lot more than what his staff does. Jobs, I don't know, he says that a lot. Business, yeah, that's still a lot more. Lies, yeah, so you kind of get the idea. Basically you can like mess around with this, like find whatever you want in there. So yeah, that's kind of cool. So yeah, another thing that to think about is that a lot of times like when you like create a tweet, like if you want to make it look nice, you typically have like an image embed or like a link to an article or a video or like image or some sort of like other like external media content, right? So like, you know, like well-crafted tweets typically have like a higher rate of like having like these like embeds in them just to make them look nicer. So what we can do is like if a tweet has an embed, then the text field is actually going to contain HTTP because it's like a link to like that links to something else. So we can search by like HTTP and see like the differences in like how well the tweet was crafted. So we do that, and like yeah. So like a lot of people said that Trump, you know, he just like tweets whatever's on his mouth. So I guess he doesn't put much time into like making his tweets look nice, and like he just tweets whatever he's thinking at that moment. So yeah. Cool. So yeah, now we want to see that. So we like explored his tweets a little bit. We have like an idea of what the data set is. We did a little like messing around. So we want to see if his tweets have any relationship to the election contributions or the contribution data set. So what we're going to do is we're going to plot the tweets alongside his contributions and see if there's some sort of like any sort of like, you know, like a relationship between them. So if you look up here, so basically what we want to do is we want to do the same thing. We want to get this data set. We want to pull out the X and Y values. X referring to the date of the tweet, and Y referring to like, you know, the popularity of the tweet, maybe a favorite count or retweet count. So you see here, it includes the created at date, not only includes the date, but the timestamp. Now this timestamp is like too granular for us to deal with, so I'm just going to go ahead and remove it from the data frame. And so one way I can do that is I can say tweets.created at, which will reassign the whole column. I can just say tweets.created at as type string. So that'll again like cast it to a string type. And then I can say apply. So it'll apply this function that I'll now type to every element in the created at after it's been cast to a string. And I'll apply this lambda x 10. So what this basically means is that this function will take in some value and only go up to the 10th element in it, or the 9th element in it. And so why is that useful? Because we want to look at just these like first 10 elements. We don't care about anything else. So that's why I did that. So we just reassign it, and now we can do like tweets.head and see if what we did was right. And yeah, so like the date is gone, or like the time is gone, and so we stripped that. So that's good. Yeah.
Earlier you just put .str and it converted to string. Why do you do .s not .s?
Yeah, I think that'll work too. Yeah, I think that'll work too. Just multiple ways to do it. Yep. Okay, so now everyone stop coding and look up here again. We're gonna do the same thing. We're gonna define another function that'll take in this data set and it'll spit out XY points. So everyone just look up and you guys can copy this code later from the GitHub. Okay, so we're gonna say def for Trump tweets and a data frame. We're gonna pass it in a data frame. So we're gonna have a tweets dict, remember as last time, which is gonna be a default dict lambda 0. And then for index comma row in data frame dot iter rows. So again, iter rows will loop through each of the rows in the data frame. It'll give you back the row that represents that and index of that row. So now we can do again strip the date. So date equals dt.datetime.strip time, and then row dot created at, because that's the field that refers to the date. And then we just pass in again the string that kind of represents like, you know, how the date is formatted. So for this case, this is again just documentation you can look up. It's formatted like this. I don't know why there's like a capital Y or whatever. It's just like how it is. Okay, and then you can do tweets tweets dict date plus equals row. Yeah. So now we have to decide like, do we want to do this for like, what do we want the y coordinate to be basically? We want to plot like when a tweet was created and like how popular his tweet was. So we can either choose. There are two good measures. There's a retweet count and a favorite count. So why don't we just add in an extra field parameter here, and then we can just index and return whatever field we pass in. We can do that. And then again, it's the same thing. We want to sort them by their like tuples and then return them. So we'll do the same trick as we did before. Sorted by date equals sorted tweets dict dot items. And then return zip star sorted by date, and I'll just like unzip it and return it back. Okay. Now, any questions on this? And like while I take questions, you guys can go and copy this code. Any questions? Yeah.
Why you want to say that? Because I don't think they can.
Where?
That last one.
Oh, unzipping it?
No.
What did you say about it?
Because I don't understand why you want to unzip.
Oh, okay, yeah. So basically, so we have this dictionary of key and value pairs, and we want to sort it. In order to sort it, we have to pair the keys and values together. So when we call dot items to, this returns an item. An item represents each a key and a value. Each item has associated a key and a value. So when you call dot items, that zips together the keys and the values.
Oh.
And then you sort that zipped pair by the key. That's just how sorted works. It sorts it by the key. And then when you want to return it, you want to return the x values and the y values separately. So you unzip it at the end. Does that make sense? Yep.
Was there a particular reason you went and converted strings and took out the time versus converting it so it types in?
Yeah, I could have done that. Could have been that too. Yeah, multiple ways to do it. Yeah, I'm pretty sure you could just pass in some flag here saying like ignore. Whatever. Yeah. Anyone else? Questions? Okay, cool. Does everyone have this copied back in their thing? Sweet. Anyone not have it copied? Raise your hand. Okay. Do you guys need some time? Yeah. So basically we said here like This is the key, and the value is some measure of popularity of the tweet, right? We want to plot an XY axis where this is like the tweet and how popular the tweet is. So I said there are multiple ways to measure the popularity. There's either the retweet count or the favorite count. So we don't know which one it is. So instead of prematurely choosing right now, I'll just add a field. And this can either be the retweet count or the favorite count. And then I can just use that to calculate the whatever popularity. So whenever I call the function, I'll have to decide which one to use basically. Yep. Okay, cool. So let's plot it now. So we have tweet x, tweet y equals 4 Trump tweets favorite count. And now we want to do the same thing for the retweet count too. So we do tweet x2, tweet y2 equals this thing, but retweet count. Does that make sense to everyone? Okay, cool. So, yeah, basically let's just now it's our last step, we just have to plot all of this stuff. So we'll create a figure. So plt.figure fig size equals 2010. And now, so what we did before when we had x and y's for the contributions was that we did plt.plot, which basically created a line plot that just connected the dots. In this case, we don't necessarily want to connect the dots of the tweets. We just want to see their kind of correlation to the overall line plot. So a good way to do that is to just do a scatter plot rather than having multiple lines over each other. And we can kind of see from the scatter plot overlaid on top of the line plot what that looks like. So instead of doing plt.plot, I'll just do plt.scatter. And then I can pass in Trump x, tweet x, tweet y, label equals favorites, because those are the favorites. And then I want to do the same thing for the retweets. So I just copy that, change it to x2, y2, or retweets. Now I want to plot the actual contributions that we had before. So I'll do plt.plot Trump x, Trump y, label equals donations. Now I can do plt.legend because I have multiple things that I'm plotting, so it'll be helpful to have a legend, and plt.show. Is everyone following here? Okay, so I'll do that. So it'll give me this kind of cool plot, but not really, of these are his their favorites and retweets, and these are his contributions. So we kind of want to make this plot bigger. We don't really care about anything that happened before here because that just kind of makes this all squished. So what we can do is we can make this a little prettier by saying plot plt.xlim. So this will define an x limit to not go past this point. You can see plt.xlim left equals dt.datetime, and just choose a reasonable point. So I'm going to do 2016 5-1. And now we replot that, and we get something like this. So this kind of looks a little better. Still, I'm not really able to see the differences between the really popular tweets and the plot of the elections in the back. So one cool thing that I can do is that I can actually scale the size of the dot by its y-coordinate. So for these retweets, I can make this thing bigger, bigger by according to how many retweets it has, or the favorites, the dot bigger according to how many favorites it has. So that'll help me kind of discern a pattern better. So what I can do is there's an S field when you plot each of the scatter plots, S is basically the size of the point. And it's a formula, you just pass it in like how to calculate the size. So, or like an array of like all the sizes. So I can just say S equals tweet Y. And here S equals tweet by 2. So basically I'm just saying scale whatever the point size is by the Y coordinate. And here by that Y coordinate. Does that make sense? Cool. So I run that, and I get something gross like that. Huh, that's not what we wanted. So what happened was that like our coordinates were just too big, or like the scale we passed in was just too big. So we're gonna have to like reduce it somehow, or like divide it by like a constant so that it's not as big. So what we can do is we just divide like tweet Y, for example, by 5,000 and like hope that works and see if, like, adjust if we need to from there. But the thing is like tweet Y is like an array, so you can't just divide an array by 5,000. So we have to convert it to a numpy array first. So just do like wrap it around with np.array, and then you can divide by 5,000, and numpy will take that as dividing every element by 5,000. So we do that, and we get like something better. Now we just see like, oh, the retweets are just like super big. So let's fix those. So we can do wrap this in an np.array for tweet Y2 and divide by 2,000 for this one. I don't know. Okay, so this is what we got. Now this looks a little better. Still, like, there's like a difference, like a scaling difference in like terms of the height for the favorites and the retweets. We want them to line up more closely because each of these represents a singular tweet. So what we can do is we can just like scale this tweet Y2 by np.array times 2. And then just to clean up the plot a little more, we can just color these. So like here we can say C equals red, C equals green. Sorry, I apologize if this is like messy and you can't follow along. It's all in the GitHub, so like don't worry, don't freak out. Okay. So here's the plot I get. This is much nicer now. So the blue line is the donations, green are retweets, and red are favorites. So clearly we can see like a really big correlation between retweets and favorites. So you know that's kind of what you expect. The more popular a tweet is, the more retweets it will have, and the more favorites it will have. But if we like look at it, we can't really find like a correlation between the donations and the tweets or whatever. And you know that's totally fine. Like sometimes you'll have a hunch about like what two things could be related. So for example, I thought, what could like affect Trump's contributions? Maybe his tweets did. So just looking at this, I can't find a relationship between the data, and like that's totally fine in data science. Like a lot of times you're gonna come across things where you have a hunch about like when something's gonna work out, and then you go down that avenue, explore, and it's not gonna work out. So in this case, it didn't work out, but it's still fine. Like we went through an interesting data set and we plotted it and we learned about matplotlib in the process. So any questions so far? So yeah, this is like pretty much like the end of like the lecture for the most part. There's like a little bit of extra visualization I did. If you guys want to take a look at that, I can load it in about like a minute. But I just want to quickly recap what we've done. So we started with this kind of motivation, which was, you can pull it up here. This was our motivation, right? Like we wanted to explore the relationship between like the election and what we thought could influence the election. So what did we do? We looked at the FEC contribution data set, which is all publicly available. So anyone could have just done this, right? So you go to the contribution data set, you download it, you put it into Pandas, and you start plotting and coming up with interesting visualizations. So we plotted Trump's and Hillary's contributions, and we found that, for example, certain events over here, as we plotted, certain events could have led to spikes in contributions. And we correlated those certain events with real-world things like, Republican National Convention or Democratic National Convention or a debate or something like that. Then we wanted to explore the data set more, so we added in a new data set to kind of compare the two data sets to see if there was an interesting relationship between the two. So we started off with Trump's tweets. We did some plotting on that, and we eventually plotted the tweets compared to the donations. Now it didn't work out in the end because we couldn't find a relationship. We're just like plotting like this. But maybe in the future, if we had some like more complex models in order to analyze this data, we could find some relationship between the donations and the tweets. I don't know. It might be true. It might not. So this is just to say, like, data science is really about like once you're having a problem, really like understanding what different factors could influence it, and like trying to like phrase it and couch it in a way such that you can understand it as much as possible. And this becomes really important, especially when you get to like higher order models, especially neural networks. You don't really understand what the neural network is doing, and so having like domain knowledge or like just like knowledge, like just some insight and being able to visualize what parts of your function or your neural network or your model are doing is really important to understanding your data set and your problem, and to leading to new insights. So yeah, anyone have any questions? Final questions? Yep.
Why did you have to turn all of like the tweet x2 and tweet y's like into NumPy arrays?
Oh, because otherwise this is just a regular array, and if I wanted to divide each of the elements in a regular array by 2000, I'd have to loop through them and do it. I can't just do divided by 2000, but NumPy is like super useful, so I can just make it a NumPy array, and then if I divide it by 2000, NumPy will automatically divide each of the elements by 2000. Okay, cool. Oh yeah.
Why didn't you scale by 2?
Oh, that's not something you had to do. It's just like, for me, it was easier to see the relationship between the retweets and the favorites if they were scaled by 2. But yeah, like that could have been like 2.5 or 10 billion or something like that. It just doesn't really matter. Yeah. Any other questions? Yep.
How easy is it to find like really organized data sets like these?
Not easy at all. In fact, Project 1, which will be released next week, is basically going to be like 3 data sets that are like pretty good data sets, but they're like all like not clean. So they'll be like split up into multiple files and like have a bunch of like missing values and missing rows. So in fact, a large part of the process is to get a good data set. And this is really important for that. So like visualizing the data that you have, understanding what values you don't have or do have, like what the structure of your data is, cleaning it up so it's something you can use is really important. And you'll be like working through that in homework one, a lot more in depth too. So yeah, it's like very, very, very important. Like probably the most important select learning model. Yeah. Cool. So Jordan's gonna have to tell you some announcements, and after that, I'll show you like a cool visualization I did based on the data sets.
Cool. If you like know me, I'm not that mean of a person. I have a lot of students and a lot of things to deal with, and just want everyone to be happy and fair. So I'm sorry if I come off as mean. I'm not. While Rohan's,
This is true.
I think while Rohan's setting up, I want to read off some of the answers to which historical figure would you hang out with and why. So first one I see is Abraham Lincoln because he is Bay. Lyndon B. Johnson sounds like quite a riot. Benjamin Franklin to share a wind bath. I'd hang out with Jesus. I don't know why. I'm not Christian, but he's a pretty influential dude. Your mom. Abraham Lincoln. His beard would be cool to see. Someone said Andrew Ng because he makes amazing advances in ML. I didn't know Ng was a historical figure, but he's still alive. FDR or Feynman because they both dead. Yeah, sad. I will ride with Genghis Khan. Karl Marx's daddy. Emoji, emoji. Okay, there's so many funny ones. Like, Tari, just stop.
Oops. Wait, how do I know if I'm recording? Okay. Where was I? Okay, so this is like in Data Science 101 in the GitHub. So this is already there for you guys. So it's just like a visualization I created at the end. So if you guys want to take a look at it, basically there's this like package called Folium, which creates like chloroplets, I think they're called, which is basically like a graph of like a map, and then it'll like color in the map with like values that you choose for it. So for example, for this one, I used Folium and I put in like a map of the U.S. states, and then I colored each state by how many contributions they had in total. So basically, like, yeah. So basically, I just like, I indexed it. The key would be like the state, that's contribution state, and then the amount. And I just did that like default dict thing that we did always before. So I have like a dictionary of like the key is the state, and then the value is the amount the total state has contributed in the election. And then I can kind of use some like Folium tricks and create a chloroplet like this. And I think hopefully, so once this runs and then that will run, you'll be able to see like a map of the U.S. and all the states are shaded by how much they've contributed. So this is like a more advanced thing. I spent like a long time doing this. I don't even know why, but so yeah, it's like it doesn't even look that good. I think you have to play around with some of the settings more, but this is just like something like I hacked together, and like it just shows like visualization is not just like, you know, like line plots or scatter plots or like basic bar plots. It's like you can do some really cool stuff. Like this map is like interactive. You can like zoom into it, like explore different regions. So it's like it's really cool. So once that loads, I'll show you guys. But yeah, thanks for coming. Anyone have any questions? Cool. Oh yeah. So homework 1 is released. It's on the GitHub. So you can just go to homework 1. It's homework1.iponb. You literally just fill in whatever it says your code here, and then you turn it into a PDF and submit it to Gradescope. And it's due next Tuesday. So be sure to do that. Also, if you want to stay around for the visualization, it's gonna finish running soon.
Dude, that's fucking lit. It's so good. How long is this usually?
Yeah.